All right, so we are looking at independent and dependent variables. And our essential question that we wanted to answer was, how can we identify or determine the independent and dependent variables? This could be when we're looking at a table or a graph or an equation. And so we started by using this foldable that is labeled two variable relationships and equations. We're going to open this up and we see that we have a problem situation here. It says David has $10 and started saving $3 a week. Now this particular problem, just like most of our problem situations, can be represented in several different ways. It could be represented in a table, in a graph, or using an equation. And ideally what we want to be able to do is represent this in all three different ways. We want to be able to take a problem situation and represent it using a table, represent it using a graph, and then also represent it using an equation. So the first thing we need to make sure is that we understand the terms that indicate if a variable is either independent or dependent. And so some things to consider. Your x value is going to be your independent variable. When we look on a graph, it is on the horizontal, which is coming across the horizontal axis. It's the first value in a table, so it's your input value. These are, all terms that when we see them written, when we see the term independent variable, when we see the input, if we see it's on the horizontal axis or it's the first value in a table, then we know that they're talking about the independent variable, and it is the x value. Okay. The second part is the y value. The y value represents the dependent variable. It is found on the vertical axis. It's the second value in a table, and the term output is generally associated with the dependent variable. So one of the things we talked about is when you have a table, we want to start getting into the habit of labeling both the independent and dependent variables. So your x value, in this case, which is weeks, is going to be our independent variable. The y value, which is representing the total money, is our dependent variable. And this goes back to the problem situation that we had initially, where it says David has $10 and started saving $3 a week. So prior to him saving, which is 0 weeks, he hadn't started saving yet, he already had $10. And then the first week, once he saves, now he has $13 because he has that original $10 plus the $3 that he's saving for the week. After 2 weeks, he'll have a total of $16. After 3 weeks, he'll have a total of $19. And we can continue to go on. This is why it will be important for us to establish the rule, right? Find the relationship between the two values, come up with an equation so that we could figure out how much money he would actually save if he was saving for 10 weeks or 20 weeks, okay? When you look at a graph, so considering the same problem situation here, one of the things I want to make sure that we do is we start labeling the x and y axis. So you'll notice I labeled it here, but I'm going to just go ahead and rewrite it there. Here's the x and here's the y axis. Again, the x is the independent variable, and in this case it's again representing the number of weeks. And then the y is our dependent variable, which is representing money. Okay. And so you'll see here at 0 weeks he has saved $10, or excuse me, he already had $10, so at 0 weeks, $10. After 1 week of saving $3 a week, now he has $13. At 2 weeks, he now has $16, and then at 3 weeks, he now has $19. So the graph and the table are both representing our problem situation. So finally we need to look at the equation and how does that relate to this. We have the x and y. It's listed that the x is the number of weeks, and I want to go ahead and label that as the independent variable. The y is the total amount David has saved, which is our dependent variable. And then to write an equation, I kind of told the students today, start here with output is going to equal, there's a value that's associated with the input, plus or minus if you're subtracting, if you're losing that. But in this case, it's the amount that he already has. So this is what he had at the beginning. And so we can use this to build, or I'll call it a structure, if you will, to build an equation. So output equals, this number here is generally, students will see the relationship in, if you have just a multiplicative relationship, it's just going to be something like, they'll say times 5 or times 3, and so it would be y equals 3x. In our case, this is it has both. There's an added feature. We have a little bit of adding, but that's for what they're starting with, and then we have the multiplication here. And so we're looking at the output being y, the input being that initial rule. We know what he started with, which was 10. And we know that every week that he saved, it's going to be a 3. So this is going to constantly stay there. That's a constant number. So that coefficient is a 3. Okay. I want to take a look at one worksheet. And this is just giving you an overview of the table, the graph, and the equation. And we're going to try to take that in pieces right now and look at a couple examples. So here we have this example piece that says it all depends. It's a little glary, but we have two different tables, and we want to determine the table and the graph that correctly relates to two quantities. Then we're going to circle our answer choice and then complete the statements below the table. So one of the things you should start to do is always start by labeling the independent and dependent variables. And then the third statement here is actually the one that we're going to use to kind of check our responses. So the statement says the blank depends on the blank. And when you're looking at independent and dependent variables, it's going to be the dependent variable which is our y value, is going to depend on the independent variable, which is our x value. Okay, so let's look at two statements and let's see which of these sounds better. The first one could read, and I'm using this information here, the number of hours worked depends on the amount of money saved. So let me just list that here. So the number of hours worked depends on the amount of money earned. So that's one statement we're looking at. The second statement would be using this second table, and I'm going to use the dependent, independent variables from there. And this time it says the amount of money earned depends on the number of hours worked. Okay. So the second statement that we're looking at is here, the amount of money earned depends on the number of hours worked. Now, which of those two statements seems to show the correct relationship between the two quantities? Okay. Does the number of hours worked depend on the amount of money earned? Or does the amount of money earned depend on the number of hours worked? Now, if you said this one, the second one, you are correct. So this is showing the correct relationship, and therefore we can come back and fill in the answers here. The independent quantity is the number of hours worked, and the dependent quantity is the amount of money earned. So when we're looking at our statement down below, we can go ahead and just take the dependent variable and fill that blank in, and then the independent variable and fill that blank in as well to come up with our complete sentence that shows the relationship between these two quantities. So the amount of money earned depends on the number of hours worked. Okay. So here's our table. This one doesn't have a graph, but we could also go from here and figure out what would the relationship be so that I can write an equation, keeping in mind we wanted output equals, there's going to be a number possibly attached to this, input. Okay, and in this case, this structure will work when you have a multiplicative comparison. So from here to here, okay, we're looking at how do we get from a 2, what's the relationship between the 2 and 1450? And I think we can figure out how much does he get in 1 hour. In 1 hour, we know that you're going to make $7.25. You're looking for the relationship here, so it's showing that if you work 2 hours, you're going to get $14.50. So I could multiply 2 times $7.25 to get $14.50. Is that true for the rest of these statements as well? 5 times 725 will give me $36.25. 8 times 725 will give me $58. And then 10 times 725 will give me $72.50. So the relationship is correct. So the output would be our y equals, and this is the value. Instead of saying times 725, we're going to replace that, and this is going to become like our coefficient. $7.25 x. The x is showing the number of hours, and so I could still figure out if he worked 20 hours how much he would earn by multiplying 20 times $7.25. Okay, so we can take a table and then create that equation. I could go and graph these if I wanted to as well. And we're going to look at this next part here. So now I have 2 tables. Now I have 2 graphs, and the first thing you want to do here again is label our independent and dependent variables so that we can use these sentence starters to get us going in the right track. Again, kind of like what we did earlier. It says this one would be the dependent variable, and this would be the independent variable. So I'm going to read the 2 statements and see if we can figure out which graph is correct. Let's look at that first one. And it says the number of footballs depends on the total weight of the footballs. Or the total weight of the footballs depends on the number of footballs. Which of those 2 sounds like it's correctly showing the relationship between the 2 quantities? Does the number of footballs depend on the total weight of footballs, or does the total weight depend on the number of footballs that you have? Okay, and if you said the second one, that is the correct relationship again. So I'm just going to bubble that one. And I'm going to fill out this information here. The independent quantity is so we're looking at independent here, number of footballs, and the dependent quantity is the total weight of the footballs. So as I'm filling in the sentence here, it should say, remember, keeping our dependent and independent labeled clearly, this is going to be the total weight of the footballs, kind of shortening that up, depends on the number of footballs. Okay. You could also take the information from the graph and start listing ordered pairs, and this graph is really small, so it's pretty hard to see the images. You can see them for some of them. I can clearly get like this one here. It looks like it's crossing right there on there, so that would be 15 footballs, and it looks like it'd be 13 pounds. I'm trying to just find the ones that are really crossing at the X and Y. This one here looks like 8 footballs, 7 pounds. So you could get the ordered pairs, and again, this is really small and probably not seen, but if I were to connect these dots, it's also forming what type of line is that? That's a straight line, and so this is showing a linear relationship. That means it's going to increase at the same increment each time. If it was a zigzag or if it curved, then that would not be showing a linear relationship. Okay, so you can take, again, just to kind of come back to those notes that we took in class, we can take a problem situation and then using that information we can build a table, a graph, and an equation, and all three of these components will be able to tell us what is the independent and dependent variables.